Start recording. Okay. I just started recording. Okay. Let me. I just saw Yidong. I just saw that you posted the document for.
Yeah. I just posted. Yeah, maybe an hour ago.
For the review. Okay.
Yeah, it's too busy for me in the past 2 weeks. So many things. Yeah, I'm sorry for that.
We all have different roles. Okay. So I know that I just saw an email from Offer. He told me that unfortunately he has some things to attend for his daughters this morning at school. So
oh, that's cool.
He won't be able to join.
Okay.
So, but it's okay. I guess we have I guess representative from each of the 3 active companies, I guess. So that's good. So okay, let me share the screen. I don't know how do you go. Do you want to share the screen or me share the screen, or how do you want to go about this? I see the pull request. I can't share that, and maybe
yeah, you can share the screen.
I didn't, as I said, I didn't have a chance to read through it. I just skimmed through it right before meeting. So let me share the screen. Share. What did I get? Somebody is admit. Sarab, are you can you hear us? Hello? Sarab, can you hear us?
Yes, Milan, I can hear you. Can you hear me too?
Yes, now I can. Okay. So I'm sharing the screen. Can you see it, guys?
Yes.
Okay. Okay. So this is the document pull request actually that Yadong made this morning, just an hour ago. So it is purpose agenda for this meeting was to discuss as per our statement of work continuation in defining next documents, which is like defining the edge scope and profile definition. So this document is in that regard. Okay, so do you mind like walking us through it and how it was your thinking, and then we can maybe spend some time. As I said, I didn't have a chance to read it through, and obviously we can comment directly to the pull request, and that is going to be a default action afterwards to do that.
Okay, great. So I was super busy in the last 2 weeks, so sorry for the delay. And yeah, this stock is not a finalized version. I see our deadline is by the end of Q2, so we still have, I guess, 1 more meeting. So I guess we must finalize this in the next meeting, and we can then submit to the TSC. So we still have some time. So now.
Well, yes, we have, our goal, obviously, but as well, there were some delays. So we'll see. Maybe we'll need to introduce more meetings if you need to more, instead of every 2 weeks, maybe we can have it every week.
No problem. Yeah.
Okay.
Great. So this doc consists of mainly two parts. One is the scope of edge, and one is the profiling of the edge devices. So actually, I added some edge scenarios because edge scenario help us to understand the scope of edge. If you only talks about scope of edge, sometimes people don't have a very concrete image of what the edge devices is, what is this capable of, how to interact with the real world, or what does it represent in the whole network. So the first part is a scope of edge. So by definition, we have to define what is edge computing. So edge computing is done at or near the source of the data. So where the data is generated, we collect, analyze, and process the data at the exact site, and then respond to the generate the output and respond to the real world. So that is the edge computing. So edge computing is large or completely performed on distributed edge devices. So the target of edge computing is any application or general functionality needing to be closer to the source of the action or source of the data where it generated, and where the system can process and interact with the real world instantly. So that is the definition and the edge. So the scope of edge is, by definition, is any systems or devices that can collect and process the data at the exact site. So I think that is all the devices that can perform such functionality is within the scope of edge. So that is my understanding that the scope of edge.
Yeah, I think that makes sense. I think what I'm understanding is that this includes obviously the devices itself that are like IoT devices or cars, something that is mobile or in the wild. Plus, it could include, as per this definition, also the processing at the infrastructure edge, right? Because it is close vicinity or to the actual devices, right? So they could be infrastructure edge computation, also could be a device.
Yes, we can. I remember last meeting we talked about fog computing. It's between edge and cloud. So here, do you mean?
So So you could say fog, right? This is the edge of the cloud, right?
Yes.
Edge of the cloud. Basically, maybe that is, maybe we could use that term fog, right? But yes, it's edge of the cloud. So maybe that should be spelled out kind of directly, but it's okay. Let's keep going. This makes sense to me.
Okay, so the second part is talking about some edge scenarios. So I get the inspiration from the Qualcomm's slides in the last workshop. So the computation for real-time applications such as facial recognition, smart city, intelligent traffic control, these are all edge scenarios, but there are still some differences between each scenarios. Like some scenarios requires super fast interaction and very, very low latency, like autopilots. And other scenarios requires very high accuracy, but they can tolerate some high power consumption, but they need very accurate response, like facial recognition. You don't want to recognize a wrong person. So here we just discuss some scenarios, which scenarios is included in the edge scenario and which will be, I didn't talk about which will not be included. So I only talk about what scenarios are included in the edge scenarios and some examples. of all those included scenarios. I mentioned about online gaming, so game servers running in the cloud, and the rendered video will be transferred to the lightweight clients, like some AR devices, like a mobile phone, like VR glasses. So this part is something I think should also be included in the edge computing, although there are still some debates whether VR glasses should be considered edge devices or not. But I think because the VR glasses generate and process the data and generate output right at the site, so by definition is still an edge scenario. So that is my
yeah, that makes sense. I mean, there is a processing that happens on device, on the site, what you say. So
yeah,
I agree. I mean, and some of it actually, this might be hybrid scenario where
yes, exactly.
Where you have part of processing done on device on site and some part of it done on fog, right? Fog.
Yeah, exactly.
So with assuming that there is some low latency link in between the the VR glass and the edge the infrastructure edge processing, right?
Yeah. So the infrastructure edge. So we should consider the whole system, like the terminals and the infrastructure, the mid-level infrastructures together as a whole, as a edge devices, or we should just separate it. So only the.
Well, I think the scope goal for this document is really to define attributes and definition of what constitutes the edge profile, right?
Yeah.
The scope is one, but the edge profile is like what defines the edge profile? What are the attributes that define edge profile? So maybe from that perspective, I'm just looking at the title of a document, so that might be a little bit confusing because it says profiling, which is different. So maybe we should rename that. But okay.
Yeah, sure, no problem.
So, but anyway, the profile definition define the edge profile attributes, right, and what constitutes that, right? And then the device like a phone or a camera, connected camera, and or the infrastructure edge. Those are two different profiles. I would think about them as two different profiles of the edge profiles, right?
Yes.
So all of them are part of the edge, and if you agree, that's why so once we define the attributes of the edge profile, then we can the next step will be to define the actual profiles, right? To say, okay, there'll be infrastructure edge, maybe there'll be VR.
I see.
VR device, the VR profile, which is maybe will be in category of connected or hybrid profile, which involves the on-device processing and on the edge processing, and then there will be some pure profiles like camera profile or things like that, right? This is where I'm trying to go, right? So if that makes sense. So I think both of them will be separate profiles, but once we kind of put parameters that we are going to use to define these profiles, then they will have there will be more meaning, I guess.
So Milan, I had a comment here on this. How do we where do we draw the line? Like let's say we have a heavy edge kind of a device, and would its peripherals constitute also as an edge device, or are we going to look at as a heavy edge device as one single entity?
Oh, that's exactly my question.
Let me elaborate a little bit more on it. Right?
Okay.
Let's say I have a high-end PC, right?
Mm-hmm.
Would I be able to create ONNX profile for the peripherals in that PC? An example is like just a camera by itself, right? So that standalone entity, would I be able to project its capabilities as a profile or not?
Okay, I see where you're going.
Or a microphone, something like that, right? And just not, it's not just a heavy edge concept too, right? Like you could even have smaller compute devices, a Raspberry Pi or something, and it still has a USB camera with it.
Well, maybe there will be. This is exactly what we need to discuss. I think, yeah, your term heavy edge. Yes, it's where do we draw the line? I think that's why the scope of the edge. So the scope of the edge is, what is it? So it seems like its scope of the edge is basically not cloud, right?
Yeah.
So it's not a data server. It's not cloud computing. So if we define that as a scope of the edge, and it's like, that means it could be fog plus fog and below, then PC in that context, yes, it is a profile that is maybe, it looks like a composite profile.
Yeah, just so by definition, not clouds is edge or fog, then personal laptop is edge because it's not cloud and it's mobile, it's smart, and it can process right on site.
Makes sense. So I think this concept of composite profile is interesting. We can probably elaborate then. If everybody agrees, that would be a good thing to elaborate more on, right? Like,
yeah, I mean, that is just my thinking on top of my head. I don't know. I mean, yeah. Anyway, that's what I think right now. Yeah, it makes sense actually. It could be composite profiles, right? It could be device that has multiple. If it so happens that we have separate profile for camera, that is a smart camera, for example, or video processing device, right? Profile. I mean, obviously that is a part of the PC, right?
Yeah.
And there is a audio processing or a smart speaker thing. Well, that's part of PC too. And so, that seems like they should have a composite profile. Okay. Okay. Yeah, good point. Good point. Yeah.
Okay, so
is that okay to describe that? Are we at a place where we can probably write 3-4 lines on it, like in the edge scenario?
Yeah, it could be. We could have a paragraph, I think, covering the possibility of well, even let me say this. I mean, currently, even the exact current scenarios, like you could add PC to this or laptop or whatever. But say, for example, car is brought up as a use case. Well, car is for sure composite.
Mm-hmm.
Composite edge device, right? So maybe we could have a paragraph talking about that the edge node does not necessarily it could encompass multiple smaller scenarios, so to speak, right? Because car, for example, could have the video processing, could have audio processing, could have VR processing. All of that is part of a car as a scenario. So I don't know if you need specifically to spell it out. Maybe it's obvious, maybe it's not. I don't know. Would you like to spell this out in an explicit way?
Yeah, I think so. I would say if it wasn't very obvious to me. So if we could elaborate that would probably help folks understand where we're going with the profiles.
Okay. Is that okay with you, Yedan? To try to.
Yeah.
Yeah. Okay. Okay. Cool.
So continue. The third part is about the definition of an edge devices is still part of the edge scope. We need to have a clear definition of what the edge devices is. So my understanding is that the edge devices is a device that provides an entry point into the enterprise or an ISP's core networks. So like mobile phone, it has an access to your carriers networks, to your ISP's networks, and like smart cities, those smart monitors, it can access to the your local police network that can transmit your the input and output of the image processing results. And so in general, edge devices normally routers and terminals that can provide access to the more efficient and more powerful backbone and core networks. So that is by definition the edge devices. So as we discussed before, I didn't include the intermediate level infrastructure here. I only focus on the terminals and all the terminal devices. So
so by terminal device, you mean here could be any connected device?
Yes, exactly.
A phone or a camera or whatever. Smart, so connected sensors or whatnot, right?
Yes.
So okay, that's fine. It includes both devices and a fog, basically. But one thing that I'm thinking of is what about? I mean, this is in general okay, but I'm thinking like, what about devices that are really not connected? I mean, they are potentially edge devices. There could be smart edge devices that have a local, processing using like sensors and they using the neural network processing, very very local, but it's not necessarily connected. And then only maybe it's something that is deployed and then collected and done. Some data collection is done offline. Now, is that something that we should consider or not?
For example, is autopilot cars connected or not? Because there are so many sensors in the car and the system just collects those data and process the data right away and give feedbacks and
So ask the Milan, so sorry to interrupt you here. Yeah. Maybe you want to elaborate what you mean by not connected, because not connected could also be a state and it could also be a capability.
Yeah, so, okay, fair. So meaning like here, this by definition edge device is something that provides entry point in the service provider core networks, routers, and so that means like there's a connectivity involved here, right?
Yes.
And so both as a state and as a capability, right? But then I'm thinking of the device that does the neural network processing, and is not necessarily, maybe it has okay, so say it doesn't have connectivity capability, wireless or in network connectivity. There is no connectivity. You have to physically access the device to get the results out. For example, it means you have to collect the device, you have to plug it in a USB port or something. And so it's not part of the network, infrastructure. There is no way to communicate through internet or other means to the device, right? You have to physically collect the device and get the output from it. So maybe some sensors sprinkled around.
So do you think it matters for the ONNX profile, like whether it is connected or not? Like, do you think we need to have different op definitions because of such an attribute change?
So I don't because actually I was like just looking. Let me share that into this, right? And
Yes. Yeah, the last one. Yeah, connected
yeah,
or
so
not.
connected or not, right? And then whether this matters or not, I think last time we said probably doesn't matter. But when I look at this statement, this here, right? It
Yeah.
assumes connectivity or defines device as something that is connected. Am I interpreting this correctly? You know, then.
Yes. But I still think all edge devices has ability to connect it into the service network. Because if it
For example,
cannot,
edge devices also provide connections into carrier and internet service provider networks.
Yeah.
So,
so it should be a state rather than a capability. So it's just a state that you are right now connected or not. It's not a capability that you can connect or not. Because I think all the edge devices should have the capability to connect to the no matter IoT
okay. So
devices.
that is the statement that I'm trying to see if we, So you're saying that they should, all the edge devices should have connectivity capability.
Yes. That
But that doesn't have to be necessarily internet connectivity then. Or do you assume internet connectivity or wireless or wired or whatever? But because what I'm trying to say is connectivity as capability needs to be clearly specified as a part of the edge device, I think. Is it required or not, and what connectivity capability means? Maybe connectivity capability means USB connectivity.
yeah, I see.
It can be something that is not necessarily infrastructure, network, network infrastructure. So anyway, that's my thinking. Maybe we should not try to tie it strictly to the internet network connectivity, or maybe we should. I mean, I'm not saying. I mean, this is just the question for us.
Yeah. One more aspect was like, how do we define, like the earlier example I was talking about, peripherals of our composite system. A composite system might have network connectivity, but when we're talking about that peripheral, it might not. The file we are going to have is in a more granular way.
Well, yeah, that is connecting point there. So maybe that's why I'm thinking we should not tie it to the internet connectivity only. We should specify maybe it has means to, the edge device.
There are so many ways of.
Doesn't have to be necessary. Let's not tie it to the internet connectivity only, but let's spell out that connectivity could be through other means, right?
Yes. So it can be IoT or Bluetooth or USB. Yes, so many.
Yeah. Okay, so maybe that's something that we should maybe clarify in this.
Yeah, I can do that.
Or could be in the context of PC. I guess it could be connectivity through PCIe or whatever, right? It could be all internal whatever bus connectivity is in the PCs these days. But so. For the peripheral connection, like PCIe, that's why I said PCIe.
Yeah. So, yeah. Okay. I can to see more about details here.
Okay.
So can we continue?
Yeah.
Okay. So the last part is about the edge profile. Actually, there are some overlaps with my previous work, and some topics already discussed in the last meeting about the metrics, about that multi-dimensional radar chart, and so actually right here I listed I remember 6 metrics. I didn't include connectivity or not, but I will add it on this time. So right now we have accuracy, size, speed, and power consumption. There's one thing, because in the original doc, the power consumption, I proposed to collaborate with the MLPerf community, but right now we have some issue. The Huawei have some issue with MLPerf, because MLPerf is more like a standardization organization. They have to comply with the EAR. So according to the feedback of my colleague, the Huawei's logo has already been removed from the membership list. So right now I cannot communicate with MLPerf right now, or if we want to, the ONNX Edge want to still collaborate with MLPerf, maybe I cannot be the representative. So there is one problem about this, and there are some other metrics like security and bandwidth. These are the fields we still need to fill it up, because I'm not sure what to talk about in the security. Last time we talked about, it's more like an end-to-end, like some.
So yeah, we had debate last time about, and I think we made a conclusion, if I'm not mistaken, that perhaps instead of talking, because security is kind of potentially wide topic, we should talk about really data locality.
Data locality.
Of security, right? And so
yes.
meaning like, is the data that is being processed on site, or is it being shipped to fog?
Yeah.
You know,
that's 2 scenarios.
Yeah, so I think maybe that is the attribute it should have instead. So I will actually, that was, I think, a conclusion last time, that we should do that. The other thing that was well, I have a question here. I have a question here in the context of accuracy.
Oh yes, accuracy.
Okay, so do we want to have this as a part of the profile? The reason I'm asking is, well, what does it mean? I mean, we should. I mean, defining the accuracy in the end, you know, all these networks. They need so here that this would mean that we need to define levels of accuracy, right? Very accurate, or somewhat accurate, or how do we put the kind of value?
Yeah, there is a problem, because actually I myself tested the first version of the Atlas series sensors, the monitor which can run the facial recognition program, and actually the first version is terrible. I and all of my colleagues tested that, and the accuracy is almost close to 0. It can not tell who is who. It's completely wrong. So and so I think for many image processing applications like image classification, facial recognition is still very important. Accuracy is still very important metrics. And there is another concern that if we move an application from cloud to edge, sometimes we have to compress the model. We have to change the OPs into the lower bits, but we still need to maintain somewhat a very decent level, something like above 90% or above 85% level of accuracy. So that is what we are talking about, how to maintain this kind of accuracy in a pretty decent level. It's not perfect, but we need to put it into a pretty high level that we can use this device and not make big mistakes.
I understand the importance of accuracy. It's just that, okay, yeah, I mean, this is tied to the actual use case, right?
Yes.
And whether the specific use case, it seems like if you introduce accuracy as attribute of the profile, one of the edge profile, then it seems like you could have profiles that are sort of, I don't know, high accuracy, low accuracy, right? I mean, in a sense, like, but then if we
is there any scenario yet that don't require high accuracy? Like,
well, I would argue that people want as much as accuracy as they can get. It is just that, yeah, I guess the tolerance for accuracy is maybe different.
Exactly.
It is interesting question. I think that is very much tied to the specific use case, and perhaps when we get to the point of defining the edge profiles, we will get to the point where I think we want to, for each of the profiles we define, we will want to specify the for sort of compliance suite, right?
Yes.
And define some characteristic to use for the compliance tests, right? So that means there will be some model to be used, and we will have to define, the testing, setup that needs to be used, and what kind of inputs and outputs are, and then that this and then there'll come question of accuracy, right? Whether what is the pass-fail criteria?
Mm-hmm. Yeah, that is exactly what we want to do in the model zoo. Must be a criteria. We don't want those bad models, bad ways into it. Yeah.
So
okay.
Let's understand, or maybe I need to understand what more. The consumer of the profile is probably the runtime component, right?
Yes.
One that is creating the graph and executing it, right?
Mm-hmm.
What would be the outcome of us, like, I understand if the profiles is just related to, describing which ops, we don't need to support all 150 ops or whatever number, right? For all the peripherals or all the edge devices. So we can have a smaller set there.
Mm-hmm.
However, if we go in the space of, like even size is okay and speed is understandable. If we go in the space of accuracy, I worry that a cat would not remain a cat if run on a different hardware.
That is what I'm also kind of a little bit puzzled here, whether this accuracy is a attribute we want to have as a part of profile.
Right.
Yeah, but let me think some more through. I mean, I guess we have some time until we have another meeting next week. I'm not going to cancel that. Or move it, so we can continue next week as well. But in the meantime, obviously I'll need to put some more thought on this. I don't know. Okay, I mean, yeah, you have a good point here. I mean,
okay. I have a suggestion, or should I just put this doc in the Google Doc and share the links to anyone so we can comment more conveniently?
So yes,
feel need to be final.
I think that was our preferred. I think, let me see, what did we say? Where is it? So if I go and do, okay, so I think we did say that we go the document, yeah, document reviews.
All right.
So yeah, I mean, I don't know, but later on we introduced this discussion material.
Yeah.
So yeah, I'm okay either way. I mean, I can comment directly.
I'll upload tomorrow.
I'm fine, honestly. Yeah, I don't want to create extra work.
I'll upload tomorrow, and we can work on the Google Doc because I think that's more convenient. Yeah, we need to discuss more about this.
Yeah, my challenge is I cannot get access to Google Docs in my company.
Oh, really?
Yeah.
So.
Okay, well that's a problem then. Then we have to stay with the.
Oh, okay, fine. Just stay with this.
You cannot get access to Google Docs. Interesting. Okay. Okay. So that's then we'll stay with the PR, and yeah, it's okay. We can comment directly here.
Yeah.
Okay. Yeah, let's do that. Okay. So other than accuracy, I think let's talk about size, speed, power consumption for sure.
Just some issue with power consumption because I personally cannot collaborate.
So the power consumption is still fine to define as one of the attributes, right?
Yes.
Interaction with MLPerf was open to discussion. I mean, that was just for us to try to align with the MLPerf Edge
I'm
working
just
group.
trying to avoid all those hazards and make sure everyone don't have any trouble. So that's why I commented here at my original things.
So we don't need to introduce MLPerf in the context of this document, honestly, because why? We are defining the attributes of the profile.
Oh, right? Yeah, I see.
Nothing to do with MLPerf. So as far as I'm concerned, in this document, this whole paragraph could be removed completely.
No problem.
And then for security, we said we should talk about data locality, and one thing that is I'm just thinking of is should it be or not the attribute that we should or consider is compute capability.
Like, are we like these are metrics, right? Like,
yes.
So
metrics or
of describing or providing some guidance to the runtime on how to handle these also. Like, I mean, it's a good example, like either accuracy or power, right? If, let's say, power is the metric, and if a device says I am of this profile, and it expresses that this is my min power or power, average power or max power, something like that, then runtime can decide what implementation to pick. Like similarly for accuracy also, it could pick, this is a very low tolerance one, and I need to have the most accurate maths going on, highest precision maths going on here. So should we define those min-max numbers for these KPIs and then have a blurb about how?
That is okay. That yes, I think yes, but that is a next step. That is defining the actual profiles. Okay, this is when defining these boundaries it will come in play. This is like for us deciding these are the dimensions or vectors we want to use to define the profiles, right? So we cut basically classes or categories of the edge devices, right? And so this profile, right now we're defining just the attributes that we should use to delineate or to define the edge profile. Now, when you go ahead and start defining edge profiles, for example, I think like for example, phone or a car or infrastructure edge or then you will put boundaries on these metrics or value to these metrics or we can call it metrics, attributes, KPIs, whatever. And then this is going to be the bounding space for this given edge profile. That's the way how I see it.
Makes sense. Sounds good.
But that's next step, right? Now
Agreed.
we have to define. So the reason I was mentioning compute capabilities. Um, um, so should that be attribute or not? I mean, I don't know. Maybe it's not. Maybe it's consumed by size and speed.
You're saying whether the power should be attribute or not?
No. Power compute capabilities, right? Can it be some device that should carry? So, for example, PC is a powerful compute, right?
Yes.
The small ARM microcontroller is very much compute limited, right? So if you want to define classes of the edge devices, then clearly in my mind there is a space where you have very powerful compute-wise edge devices, but then you have very, very limited compute edge devices.
Yeah, I was thinking maybe we can express that, like of course speed and size and power would, basically reflect the compute capability too. The other aspect is just the maths, like, whether something is capable to run, FP6, like 64-bit or just int8 or, less number of ops. If it's an LST, audio DSP device, it
Yeah. So that should be
better suited to
compute capability, actually.
right? Like if it's an LSTM only device, and so if we can express it in op terms, then we're good. But compute power is probably too generic of a expression to just, maybe it needs to be then.
Okay. Okay. Okay, so let's go with it.
Like op capabilities, would that be a better term rather than compute power?
Compute capabilities, yes, that's what I was I think saying. I mean, power consumption is one thing. Obviously, it could be. I mean, even though you could argue that power consumption and compute capabilities are somewhat connected, but still, compute capabilities is like, oh, maybe it's a device that can only do fixed point ops.
Exactly.
And that's maybe that's why it should be attribute.
So okay, so I think we're on the same page. What I understand from your definition of compute capability is, things like if a device can only do integer maths or can only do 5 ops in ONNX, we want to express that, right? So what I want to say is that the term compute power is probably too broad and wide. It can be misinterpreted as other things.
I don't know. I wasn't. You want to? You're talking about power consumption, or why are you
compute? The very first definition in your earlier PowerPoint slide that you were showing, right?
Oh, sorry. Yeah, this was the only kind of
first line.
Compute resource constraints.
Correct. I'm seeing that of all these points here, right, other than accuracy, all of them are reflected in the document that we were seeing earlier.
Yeah.
So what we are not seeing is compute resource constraint.
Yes.
And your definition, from what I understand, of compute resource constraint is data types and ops, right?
Yeah. Or not just that. It could be that is a part of it for sure. I mean, it could be really, pure, MIPS MIPS capabilities of the device, right? Like how many MIPS or GOPS or whatever can it crunch, right? And should that be attribute, right? So there is an aspect of the ops and data types. There's aspect of pure compute power. Like when I say compute power, I don't mean watts. I mean compute capabilities, right? In a sense, like really, how many instructions per second can you run, right?
Okay.
So that is where there's potentially. So this is like I'm thinking like in the context of it could be again PC versus a small microcontroller. And microcontroller has much more less compute capabilities in terms of the instructions per second and whatnot, but also it could be limited in the context of type of data mat or data types it can do, or operator types it can do. So those two things maybe should be actually separate consideration. And maybe if we since we said the operator subset is going to be part of the profile, then maybe that is defined to that, like data types, because you could say, to your point, this profile does only integer mat tops, right?
Makes sense.
Yeah, but the actual MIPS capability of a device, is that something that it needs to be a separate attribute or not? I'm not myself clear yet, but we have it here. But and I thought that it might be useful just because of separating powerful CPUs from the really small CPUs.
Makes sense.
Yeah. So, okay. Okay, so then I guess we should then are we in agreement that we should add this compute capabilities or compute constraints or how we call it, right? To the list?
I agree.
Okay. And data types and all that, I think that could be covered through just sub-selection of ops.
Yeah.
Okay. Okay. So I guess we came to the thanks Yedong to preparing this. It's a great starting point, and I would say that we will continue next week, next Wednesday, and then obviously encourage everybody to put read through this again, put extra comments directly into the.
Milan, can you just comment on the doc since it's 11 p.m. So
Can I what?
have to? Yeah. You just comment what we are talking about in the sections where we are talking about like accuracy, like power, like yeah, just comment on the section. If this section we are talking about, we need to change or clarify. Yeah, just comment here. What need to clarify. And
yeah. And actually telling to everybody. So comment.
Yeah.
Here.
It's too late here, so I can only work tomorrow.
Yeah, no. I'm not saying now. I mean, next week, next Wednesday, we have another meeting. So by next week, you also could update some of the.
That's great. That's great.
And then we also will comment directly into the document here in the PR.
That's fine.
Yeah.
Milan, can you copy paste the link that you have on the top to the maybe the window somewhere, chat window or something?
Yeah, chat window.
Yeah.
Yeah. So I can. Yeah. actually it should be just pool 6, right?
Yes.
Let me test this. Yeah. Okay.
Perfect.
Okay. Sounds good. So we are about out of time, and I will post this recording right away and to the YouTube channel and some meeting minutes maybe a little bit later, but I will post recording right away. Sounds good.
All right. Yeah.
Thank you, guys.
Thank you, guys.
Good night. Good night,
Yeah. Thank you. Good morning, guys.
Okay. Bye.
Goodbye.
Bye.